These will be the notes for section 12.3, inscribed angles. As we said before, we're going to be moving around in different parts of chapter 12. Inscribed angles are something that's pretty easy to remember, so hopefully it'll be something that'll be one of the easier lessons. The objectives are I will be able to find the measure of inscribed angles, and I will be able to find the measures of angles inscribed of polygons. So what is an inscribed angle? It's an angle whose vertex, so remember vertex would be like this point B. It's where the angle is formed. It's like an elbow point. So an angle whose vertex is on the circle and whose sides contain chords of the circle. So we talked a little bit about chords in our first section on circles. They're just something that goes from one point on the circle to another. It's not a diameter because remember a diameter goes through the center of the circle. An inscribed angle might go through the center of the circle. It doesn't have to. Most times they don't. So an example of this is angle ABC. Points A and C are on the circle. Segment AB and segment BC are chords. And point B is the vertex. It's also on the circle. Related to this is an intercepted arc. It's the arc that lies, so let me change colors here, inside the inscribed circle angle and has endpoints on the angle. So we can kind of think of an inscribed arc as a Pac-Man type figure, and where the mouth is open, where I put it in red, that's the intercepted arc. So arc AC is the intercepted arc of, it's not or, that should be of angle ABC. So the inscribed angle theorem says if an angle is inscribed in a circle, then the measure of the angle is 1/2. So 1/2 of the intercepted arc. So we have that arc and that angle. So we have the measure of angle YXZ is equal to 1/2 the measure of arc YZ. So one way you can remember this is the maximum length for an angle is 180 degrees. The maximum length for an arc is 360. So that kind of makes sense where that 1/2 comes from. We also have arc measure. So if an arc is formed by an inscribed angle, then the measure of the arc is twice, 2 times, the measure of the inscribed angle. So the measure of arc PR is equal to 2 times the measure of angle TSR. So that means this arc here is double whatever the measure of this angle is. The last thing we have is a theorem here. It says if 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. So remember our symbol for congruent was the equal with the tilde on top. So if we take a look at angle 1, we see that its intercepted arc is arc GH. And if we take a look at angle 2, we see that its intercepted arc is GH. So that's why angle 1 intercepts arc GH. Angle 2 intercepts arc GH. Therefore, remember that from earlier on in the year, angle 1 is congruent to angle 2. So remember this symbol here means therefore. That's a little review of our logic and reasoning unit. And it makes sense because those angles have to be half of what arc GH is. So moving on to page 2, we have a lot of examples, and these examples are pretty easy. So this 17 degrees, that's this angle here. So x is going to be equal to 2 times 17. Remember, the arc is double the inscribed angle, so x is equal to 34. So this one here, we have this arc here. This needs to be 180 degrees because this is 90. So we get 4x plus 8 is equal to 180. Subtract 8. We get 4x is equal to 172. And we divide by 4. We get x is equal to 43. So moving on to question 3, we know that 3x has to be 1/2 of 138. So 0.5 times 138 gets us 69. So this has to be 69 degrees. So if 3x is equal to 69 degrees, x will be equal to 23. So right here for number 4, this one might seem a little trickier. This is an isosceles. Well, it's not exactly an isosceles triangle, but we have two congruent sides. That means this side here needs to be 110. So remember, the arcs need to be congruent. So x is going to be equal to 360 minus 110 minus 110. Sorry about those little errors. So we get 140. So this is one of the theorems that we had earlier. Remember, this arc right here is that big. Or the intersecting arc, I should say. And the intersecting arc for this angle of 80 degrees is the same thing. So that means 80 needs to equal 3x plus 5. And then it's a simple algebra problem once you set it up. So if I'm going too fast for you, you can slow the video down. You can also pause it and make sure you copy everything down. The last one we have is number 6. It says ABD, measure of angle ABD is 44 degrees. And we have to find what ACD is. So here's ACD. We see that its arc is right here. And we see that ABD has the same exact thing. So that means that the angles have to be congruent. So that means they have to be 44 degrees, angle ACD. All right, number 7 says in circle S, the measure of arc KL is 80 degrees. So that means this right here is 80 degrees. And the measure of arc MN is 60 degrees. So they ask us for the measure of angle 1. So angle 1 is this right here. So we have this arc. If we have what this is, we'll be in good shape. What the arc is, then we can find it. So what we need to see is that KM is a diameter. So that means this arc that I shaded in black has to be 180. So KN needs to be 120, MN 60, so that gets us to 180. And similarly, this needs to be 100. So now we can find these out pretty easily. The measure of angle arc has to be 1/2 times 100, which is 50. The measure of angle 2 has to be 1/2 times 120, which is 60. The measure of angle 3, 1/2 of 60, which is 30. So the measure of angle 4, I think you should be able to get the idea. I want you to do 4, 5, and 6 by yourself. So if I erase this, the thing that you need to remember is, let's rewrite those numbers. 80, 60, 120, and 100. So you just take each angle and you should be able to find half of what the arc is. So for number 8, we say in circle A, remember that means A is the center. In circle A, we're told that the arc XY is 60, arc YZ is 80, and that WX is congruent to WZ. So that means this arc right here needs to be 360 minus 80 minus 60. So that means this whole thing needs to be 220. Since they're congruent, that means each of them needs to be 110 degrees. So once you have this information, you should be able to do these by yourself too. You have enough information to do number 8. So do these on your own. You have all the information you need. They're all inscribed angles. So moving on to the last page, we have several theorems. It says if an inscribed angle, so there shouldn't be an S here, intercepts a semicircle, then the angle is a right angle. So we already alluded to this. So we have this arc here, because remember, that goes through the diameter, so that has to be a right angle. Also, we know since this is the diameter, angle BCD has to be a right angle. So to write that out, angle C intercepts arc BCD. Remember, therefore, the measure of angle A is equal to 90. Or sorry, the measure of angle C, not A. And we also have angle A intercepts arc BAD, or BCD. I have some bad letters here. This is BCD. This is BAD. Therefore, the measure of angle A is equal to 90. Like I said, we've already talked about that one. This theorem says if a quadrilateral is inscribed inside a circle, then its opposite angles are supplementary. So its opposite angles are supplementary. So this isn't too hard to see because we have this arc plus this arc, and they form the circle. So that's where it comes from. So the measure of angle E plus the measure of angle G is equal to 180 degrees. The measure of angle F plus the measure of angle H is equal to 180 degrees. So we're told to find the value of each variable. Again, we have this right here, so we know that 3x is a right angle. Divide by 3, we get x is equal to 30. This one here, we know that opposite angles are supplementary. So 2x plus 100 is equal to 180. Opposite angles are supplementary. Subtract 100. We get x is 40. And if I want to solve for y, do it over here. Y plus 87 is 180. Subtract 87. So we get y is equal to 93. So I'm going to have you do 12 and 14 on your own, and we'll do 11 and 12 together right now. So again, we have another inscribed polygon, inscribed quadrilateral. So we have x plus 12 plus 2x is equal to 180. Opposite angles are supplementary. 3x plus 12 equals 180. We subtract 12. So we get x is equal to 56. And if I solve for y, so just simple algebra. Y is 20. So the last one here, we have some words, but that's okay. This quadrilateral QRST is inscribed in circle M. The measure of angle Q is 87, and the measure of angle R is 102. Find the measure of angle S and the measure of angle T. So the measure of angle Q plus the measure of angle S equals 180. We'll call it S. So I'm doing substituting. So the measure of angle S is going to be equal to 93. And I can do the same thing, and I'll see that the measure of angle T is 78. I hope this is helpful. Please come to class prepared with any questions you may have, and have a great day.